Dear viewers, this video which is covers the distance protection with the Mho relay, or it may be called as the admittance relay. Mho relay, and it's called as the admittance relay. In earlier case, we are seeing the basic operation of the impedance relay. Impedance relay. Now we are going to see that is the admittance relay, or we are going to see in names of Mho relay. So how the Mho relay which is differ from the impedance relay? First, we are going to see the uh, difference in terms of torque equation. Here, that is the two quantities which is we are going to consider. One is operating quantity, another one is a restraining quantity. So the one quantity is also which is a function of the voltage square. Another quantity which is also function of this the V into I, right? So here, for simplifying this above equation, this is the minus term operating and restraining, which is equate with the both the things. Again, we are going to obtain this is the constant K2 and K1. Here, that is 1 by V, 1 by V, or I by V, that we are going to obtain based on the trip value is to be function of this cos phi minus alpha. So what is the alpha? Alpha is the line plane that is in the Rx diagram, which is lie here. This is the alpha. It is that the zone which is available for that M1, M2 and M3. That is the M1, M2 and M3. That is the number of zones which is covered, right? That is if it is we are going to see the basic concept of that the relay, which is y, that is the y, that is admittance cos of phi minus alpha. So this relay which is also is a called as that the direction operation also, right? Directional the operation also will also going to be considered. So this is induction cup type Mho relay. So here that is one of the quantity we are given, that is current. Another one quantity we are applied here, that is the voltage. Again, this voltage which can be polarized point. Versely, we have going to connector. So please see here, that is this is the positive point, negative point. This is the contact M, that is the Mho relay point at is M1, that is the M2 and M3. So these M1 and M3, that is a seal in relay which is connected by the T3 time 3, that is the timer based, that is the block which is available. Again, that the seal in relay coil, that is these are all that seal relay in relay coil. This is auxiliary CB auxiliary contact. So this is nothing but the CB auxiliary or auxiliary switch based contact. Already you are studied in the machines how the contacts will be working, right? So on base of that knowledge we are explained here. So these are all that the flags. Okay, so what is the torque equation of this relay is, that is one quantity is that the voltage and current, and another one quantity is the voltage square. It is also a function of the cos phi minus of alpha. So which is the trip function which is always the basic equation is, that is y into cos of alpha, that is y into cos of alpha, which means please see. So there is vi cos of phi minus alpha. So we are omit this that is square. Again, that is that the v by v, one of the v will be cancelled. Again, that is the another v, this v is cancelled. Again, I which is available. Again, here v is available. We want to estimate k2 divided by k1. So we have going to obtain this I by v. So I by v, as usual we are going to obtain the y. So the relay which is called as the Mho relay, right? Now you once again I am explain the torque equation is function of the V square, that is operating quantity and restraining quantity. One is the V square and another one is the V into I. So please see, this is the I, this is V, that is V into I, that is the point, this point. And another one thing, we are going to get V square value. This is that the V square value, the coil which may be wounded here. So based on this analysis, the square term, and that here you may see square term, and that the operating quantity and the reasoning quantity both are equate, and V it will be cancelled. Then I by V, which is called as Y. This is called as the Mho relay. So this is the entire explanation. So what is the alpha? Alpha is this is that nothing but the one of that impedance. So this is nothing but the one of that impedance. So here that is the function of that is R plus J of X. So we are going to take as Z. This Z based on the J value, we are going to obtain the alpha. This is the alpha we are going to used for the function. So next one is the angle impedance relay, angle based impedance, which is that ohm based relay. So the reactance relay is a particular case in the angle impedance relay. So the reactance relay, which is also going to called as the angle impedance relay, because of this the angle of angle alpha. Okay, if the alpha is changes, again that is this degree, that is this particular point is changes, again ZR will also changes, and Z value is changes. So the entire impedance value, which is also function of the alpha, so this is called as the angle impedance relay. Once again I am repeated, this is Rx diagram, this is for resistance and reactance. So the combination of R plus J of X, the alpha, that is the angle we are going to obtain, is the combination of R plus J of X in the J quantity. That is that the imaginary part, how it can be created. So if the alpha is changes, as usual, that is the Z is changes, and the impedance zone coverage also changes. But in case of angle impedance relay, have any which is governs the insulation of the characteristics with respect to R axis. This is the resistance R based axis, which is control R, which can be contribute the major part of that impedance. Okay, so when the swing is very large, the impedance seen enters into Mho circle and the relay trips. Suppose the swing means, if it is the power system swing, that is the power system swing. Okay, power system swing is occur during that time, that is the change of that the Z value is changing. So based on that swing value, we are going to obtain or change this alpha value, and then we are going to retain the position. Okay, so this is known as the blinders. A special relay known as blinders can be used to prevent the operation of power swing. Blinders. Okay, so this is that the part. So which means a special relay known as blinders can be used to prevent this operation of swing. So what operation blinders? They are going to control this alpha. Okay, right. Okay, so this is that the Rx diagram of that the relay consigns. So this is the trip zone, this is the retain zone. We are going to obtain. So OA is a ZL. So what is that? The point is O. This is that A, which is we are going to ZL. That is line impedance. AB is the SB. That is the specific point. Again OD. This is this to this point. OD. Okay, this is the OD. and C is the electrical. This is the circle. If it is in the plane, we are going to obtain the directional operation. The tripping action is occurred in this zone. Suppose if you want to change, simply we have changed the alpha value in the minus or in plus of alpha value. We are going to change the directions also, right? Okay. So next thing, the reach distance of the relay system. So if it is Mho relay and the distance relay, Mho relay or in the distance relay, the important term is reach. So what is this reach? So already in the earlier case, we are seeing the very basic, that is in the earlier videos. Please see, that is here the fault 1, again fault 2, again fault 3. So the what is the set point? That is, we are assumed this circle. Please assume this circle. So this is the point. This is the point. This point assumed as a Z set point. Z set point. Okay, this is a Z set point. So this Z set point, whenever the impedance which is Z of relay system which is less than that the Z's impedance, the relay which may be going to trip otherwise, but due to some other reason, the system which is not obey this rule, the system which is not obey this rule, so that the system or reach is called the under reach. Okay, in other words, the maximum length of the line which is the relay can protect, which means the tendency of the distance relay restraint not operate at the preset value. So this is the point. That is the preset value of the impedance, or the impedance less than that less than the preset value is known as the under reach. So the relay value which is less than that, but it cannot be operated. This is the C, that is the pre-fault. Due to presence of this R resistance, R plus G of X based on that this alpha. So if the system which cannot be tripping, at the same time, what is meant by the overreach? Suppose if the fault is occurred, that is the fault 3, already we are seen here, that is F1, this is F2, and this is F3. F3, that is the third zone, that is the relay impedance, that is ZR, which is greater than the Z set point. So the tendency of that the relay operating impedance is larger than the preset value. So the ZR, which is greater than that Z value, the fault beyond the preset reach is known as overreach. So this is called the overreach of the relay. The main reason for the overreach in the preset DC offset fault current in the wave. So the presence of why the system which can be reached the overreach operation, the reason is DC offset in the fault current. In the fault current, that is DC offset is available, it may be going to change the reach point of the relay. Okay, so this is the percentage transient based reach point. So this is Z of minimum, that is normal conditions. So that is no off conditions. So this is no offset in the fault current. Suppose if it is in the fault current, it is offset is which is available, the transient overreach in the distance relay, which may be the changes, no offset in the fault current, because there is no DC, that is DC offset. But here the DC offset, suppose this is that the current, which is available due to presence of these again available, but this is the 0 point. However, it may be going to oscillate as this is. So this is the DC offset. Okay, this is offset from the 0 point, the some value we are going to be upward side, that is the superimpose, that is lifted. So there is no positive and negative equal quantity. equal half cycle. So this is during this DC offset, the reach problem will maybe occur in the relay systems. Okay, this is the quadrilateral relay. Based on that reactance, that is the change of reactance, combination of the reactance relay, we are going to obtain for this quadrilateral. This is quadrilateral relay. So that is, it is possible to develop the relay characteristics based that is other than the circle. Depends upon our requirement, and of alpha, based on that alpha value we are able to easily change. Okay, so up to this we are seeing. So this is that the elliptical relay. Again, that is the position will also change. This is obtained by using the solid state. This explanation we are going to after seeing the solid state relay. Okay, because this is no moving point, which means if it is, that is, what is that, the positive, again that is the negative quantity. So one is the positive, and here we are going to obtain the positive, here we are going to obtain the negative. Both the values, it will be equal or not equal. Based on that balance point, we are going to obtain the elliptical characteristics is less affected by the surge or occupy less Rx diagram, which means the voltage here applied, this voltage which can be fed into the circuit. So the DC current we are obtained here. Again, the CT will also going to apply for this circuit. Okay, the relay which is available. So V minus K into IR divided by I is that is M and I. Suppose if V is that is greater than I for the normal operation, that is the normal operation. Okay, so during the fault, during the fault, so that is that V is less than the I. So that the current which is introduced here, again that is the relay which is energized, that is a different path, and here also energized this point. Again, this which is may going to lead this point, this is V minus Ki into Z RF. Then the relay, the resultant current which may be going to flow in the relay will be operator. So this operation, the power surge which can be controlled by this the biasing value K into ZR, and that is the biasing, and this is the MI value. Okay, so up to this we are seeing the distance relay, the electromagnetic type based distance, impedance, reactance, and more type of relays. Okay.